Now okay, sir?
Okay, madam.
Okay,
I think some connection issues are there today. I don't know why. Okay.
okay, sir.
Okay. So if I equal to 8, what does it mean? If I equal to 8, what does it mean? Already 7 passes are completed now.
Yes.
Pass number equal to 8 means 7 passes are completed now. If
Yes, sir.
one
Yes,
pass
sir.
is completed, nth position, the actual element will be there. Second pass is completed means n minus
Sir, you are not audible, sir.
Hello?
Sir.
So I'm sorry, is the screen visible now?
Yes, sir.
I think there is some internet issue. Every time it is getting disconnected.
Okay, okay, sir.
Okay. So now, if pass number equal to 8, that means what? 7, each pass puts one element in its own position. First 7 passes, they must have put 7 elements in their own respective positions, no? In the final sorted array.
Yes, sir.
Yes. So that means now what are the remaining elements? We have 1 to n minus 7 positions. So these are only positions. Positions 1 to n minus 7. So now 8th pass, what are the elements that we consider? 8th pass, what are the elements that we consider? 8th pass, we consider array
N minus
whose elements are in positions from 1 to n minus 7. 1 to n minus 7. N to n minus 7.
1 to n minus 7. Yes, sir.
Okay, 1 to n minus 7. But in order to compare elements which are present at positions 1 to n minus 7, we are comparing elements in pairs. So this is 1 pair, 2 pairs, 3 pairs. Like this, how many pairs we get? How many pairs we get? If the elements are from 1 to n minus 7, how many pairs? Number of pairs here. Number of pairs. We compare. How many pairs we compare?
N minus 8, sir.
N minus 8 pairs, no? Is that correct? Is that correct?
Yes. Yes, sir.
Is that correct? Okay. Okay. Now, so that's why this is pass number. So J value, it varies from first to 1, 2 we compare, next to 2, 3, next to 3, 4. What is the last? What is the last comparison that we perform? What is the last comparison that we perform? What is the last comparison that
N
we
minus
perform?
8 and n minus 7.
N minus 8 and n minus 7. Is that correct?
Yes, sir.
Is that okay? Is that so? That's why when the pass number is I, what are the comparisons that we valid comparisons? 1, 2, 2, 3, 3, 4, and so on, and so on, and so on, and so on, and if 8th pass, what are valid comparisons? 1, 2, 2, 3, 3, 4, and so on, n minus 8, n minus 7. No? Now, can we generalize this? In 8th pass, what are the array elements that we need to consider? What are the array elements that we need to consider? What are the array elements that we need to consider? 1 to n minus I minus 1. 1 to n minus I minus 1. Is that correct? Is that correct? Is that correct?
Yes, sir.
Okay. This is correct now. Okay. Now accordingly, what is the algorithm? What is the algorithm? Each pass J value varies from 1 to in pass number I, pass I, J value varies from 1 to 1 to 1 to 1 to 1 to n minus I. This, I think this minus 1 is not okay. 1 to n minus I. Is that correct? Is that correct? See, that means here the last comparison is n minus correct one. You know, this is n minus 7 means this is one more. So this will be n minus I.
+1 होना चाहिए sir.
No, no, brother. So we compare elements like this. Then every time we compare adjacent elements. If they are out of order, we swap. That's what we do now. If they are out of order, we swap those elements. Is that correct? Okay. Okay. Now this is correct only. This is correct. Now you tell me what is running time of this algorithm? What is input size? Is it n or not? Input size, is it n or not?
Yes, sir. Input size,
Yes.
yeah.
What is most important operation here? What is most important operation?
Comparison.
Comparison.
Comparison. Let T of n be the number of comparisons when n is when n is input size. When n is input size. Now T of n value, it depends only on n or actual values in the input also. T of n, it depends only on n or actual values in the input also.
Only on n.
Only on n. Every time, no, we compare successive elements. If they are out of order, we change we swap that. That's all, no? We are forced to compare, no? Okay, that means it depends only on depends only on n. Now tell me what is T of n then? What is T of n? That means we are counting how many times this operation is performed. Why are we not bothered about this operation? Performed in fourth step. Why are we not bothered about that operation? Number of times swap operation is performed is not more than number of times comparison is performed, no? So that's why we are not even counting that. We are not even counting that. So now tell me what is T of n value? What is T of n value? What is T of n value? This operation is performed for each value of j from 1 to n minus I.
n minus I.
N minus I one time. This
Yes, sir.
entire thing is performed for each value of I from 1 to n minus 1.
Yes,
Now
sir.
what is this value? I equal to 1 to n minus 1. What is
N minus
I?
I.
This is n
N
minus
minus
I. So it is nothing but 1 plus 2 plus and this 1 plus n minus 1. Is this correct? Which is same as n into n minus 1 by 2.
Yes, sir.
What is order of growth of T of n? Order of growth of T of n. What n into n minus 1
N
by 2?
square.
What is its order
N
of growth?
square.
N square. Once you know that its order of growth is n square, then we can represent it. So now we know that T of n is n into n minus 1 by 2. That is 1 by 2 into n square minus 1 by 2 into n. What is its order of growth? We know that is n square. Now you tell me what is running time of this algorithm. Can we represent it as big O of n square? Is this correct? Is that correct or not? Big omega of n square, is that correct or not? Theta of n square, is that correct or not? Now you tell me, are there any best case, worst case, average case in this case?
No,
Is there
sir.
any? No.
No, sir.
So now all cases, what is the running time?
Same.
Theta of n square also you can write, or big O of n square. Now you tell me what is the space complexity here? What is the amount of additional space we take here? Okay, let me go back to algorithm. You see this and tell me what is the total space we require in this algorithm? Array A, n elements are there, so n memory units are required, n locations are required. Variable I, you require something, 1 unit. Variable J, 1 unit. That's all, no? So that means what is the total amount of memory we require here? What is the amount of memory that is required?
N plus 2.
N plus 2 or n plus 3 is swap, no? There also, if you take some temporary variable, then it will be n plus 3. In general, we can call it as n plus some constant. N plus some constant. That means what is the space
sir.
complexity of this algorithm?
N.
N. And that means using asymptotic, order of growth is n. Order of growth is n. What is space complexity? Big O of n, is that correct or not? Space complexity is big O of n, is that correct or not?
Yes, sir.
Big omega of n, is that correct or not? See, if order of growth is n here, once order of growth is n,
Sir, one doubt, sir. Excuse me, sir.
you can also write it as theta of n. Is the screen visible? One of you please respond.
Yes, sir.
Yes, sir.
Okay,
Sir.
okay, thank you. Okay, okay.
Sir, one doubt, sir.
Please tell me, brother.
Algorithm second step, sir. Why are we taking j from 1 to n minus I, sir?
Okay. So first time, how many elements we have, brother? Okay, let us take this. 1, 2, 3, 4, 5 elements are there. Correct, na, brother? What are the indices we compare first? 1 and 2 we compare. Correct? When I equal to 1, first to pass, what are the indices? We compare these two elements or not? Next we compare these two elements or not? Next we compare these two. Next we compare these two. That means 1 and 2 we compare. 2 and 3 we compare. 3 and 4 we compare. 4 and 5 we compare. Is that correct? Is that correct? Is that correct? Okay.
Yes, sir.
So what is 5 here? This is same as n value, no? Correct. So up to last element, if I take, the next element I am increasing its count, no. What is that index value? I go up to 4 and compare with the next element, that is if it is j plus 1 element I am comparing, no, in for loop, sorry, if loop, if condition. Is that correct?
J plus 1 element.
Is that correct? See, brother, this is j value. If I equal to 1, what are the j values, you tell me? 1, 2, 4 or not? If I equal to 1, what are the j values? 1, 2, 4. Is that correct or not? That means here I am comparing a of j and a of j plus 1. Every time we are comparing j and j plus 1. Is that correct? J and j plus 1 we are comparing. Is it okay, brother?
Satisfy we have to take one less, no, sir?
One less. That's why one less. No, 1 to 4 only I have taken. No, there are total 5 elements, but we have taken up to 1 to 4. No, brother. See, j equal to 1 to n minus 1. N minus 1, correct? No. When I equal to 1, the elements we are considering is 1 to n, but the comparisons we are doing is n minus 1 only. That is 1 to n
From
minus 1.
1 to n minus 1. Yes, sir.
Correct only. No. When I equal to 2, 1 to n minus 2. When I equal to 3, 1 to n minus 3. Is that clear, brother?
Sir, in the third step, we are doing j plus 1. Maybe that will take care of comparing last two elements if it is last pair.
That is that's
J
why
plus
j plus 1 is there. That's why with j value we are going up to 1 less. No, see, if we want to compare 5 elements, I am going up to 4th element only. No, every time when j equal to 1, I am comparing a of j and j plus 1 and 2. When j equal to 2, I am comparing a of 2 and a of 3. When j equal to 3, a of 3, a of 4. When j equal to 4, a of 4, a of 5. Over. No. Is it clear or not clear, brother?
Yes, sir.
Okay, I hope you understood this. So now tell me what is the total space it requires? What is the total space? What is total? N plus some constant. What is its order of growth? What is its order of growth?
N.
N. Now now the space complexity, it can be represented as big O of n. Is that correct? Big omega of n. That is also correct. All are correct now. Once you know that its order of growth is n, all these are correct. Now you tell me what is the amount of additional space it requires other than input? What is the amount of additional space it requires other than input?
In this case, 2 for 2 variables.
Constant.
2 or 3 or 4 depending on implementation. No, number of additional units is 2, 3 or 4. That means amount of additional space it requires is how much? It is a constant. That means it is independent of input size. Independent of input size. That means this type of algorithm is called. In-place sorting algorithm. Amount of additional memory it requires is other than input it requires is constant, which is independent of input size. Hence, this is called in-place sorting algorithm. Okay. Now tell me what is the space complexity here? What is space complexity? What is space complexity?
Order of n, sir.
Big O of n, or what are the other answers? If we want, we can write theta of n also, big omega of n also. All are correct. All are correct. What is additional space it requires?
Constant.
Big O of 1 or theta of 1 we can write. That means, is it now this algorithm, is it in place? Is bubble sort in place?
Yes, sir. It is independent of n in place.
In place sorting algorithm or not? Is the bubble sort in place sorting algorithm? Yes. Why? Why? amount of additional space is
Independent of
amount of additional space is
independent of
additional
input space.
space is independent of independent of input size.
N.
Input size, that is n. Is that correct? Is that correct? Okay. Now, similar to that, you can even count how many times this swap operation is performed. Okay, now how many times the swap exchange operation is performed. Okay. This also you count. Again, we'll discuss. Okay. Now, now in this bubble sort algorithm, see, at some stage, these are different passes. No, pass 1, pass 2, like this. If there are no swappings, what does it mean? If there are no swappings, what does it mean?
It is already sorted.
Thank you very much, ma'am. So, no swappings means, that means it is, for example, 10, 20, 30, 40, 50. Here we compare these two. Next we compare these two. Next we compare these two. Next we compare these two, and we don't do that. Next iteration, what is that we do? Next iteration, what is that we do? 50 we don't consider. 10 and 20, 20, 30, 30, 40. Next, 10, 20, 30 only we consider. Compare 10, 20, 20, 30. Then only 10, 20 we consider. Is that okay? Here, are there any swappings? Are there any swappings here from first to pass to second pass? Are there any swappings? Second pass to third pass, are there any swappings? Third pass to fourth pass, are there any swappings? No. That means if a particular ith pass, if there are no swaps, what does it mean? It implies that I plus 1th pass also no swaps. I plus 2th also no swaps. Pass also no swaps. And swan n minus 1th pass also no swap. Correct, no? That means what? When does this case occur? First element is less than or equal second element. Second element is less than or equal third element. It is less than or equal fourth element. Less than or equal fifth element. Less than or equal sixth element. And swan less than or equal last element. That means what? Already elements are in sorted order, no? Already sorted. If the elements are already in sorted order, is it worth going for next pass? We don't get any advantage, no, by doing that. No, we can stop here itself in a particular pass. If particular pass, if a pass does not have swaps, we can stop there itself, no? We can stop there itself or not?
Yes, sir.
Okay, that's what we do, so that we'll get some improvement. No, we can save some comparisons or not. We can save some comparisons or not. Okay, this is the last point. So that's what we do. So each pass we use one variable, that is swap count. How many times for each pass? I equal to 1 with this. If after each pass is completed, we check whether swap count is changed or not. Whenever swap takes place, we increment this swap count value. Whenever there is a swap, that we increment that swap count. After that pass is completed, we will check whether there is any change in count value. If there is any change, we say that, okay, already there are no swaps. That means already sorted. Already sorted. We stop there only. Correct? Small change. Okay, small change. Now you tell me what is input size in this case, this algorithm. This is modified binary set bubble sort algorithm. What is input size? Is it n or not? What is most important operation here? What is most important operation?
Comparison.
This is also comparison. Now you tell me, let T of n is number of comparisons performed. When n is comparisons performed, when n is input size. When n is input size. Now T of n, it depends only on n or actual values in the input also. It depends only on n or actual values in the input also.
Values of the input also.
It not only depends on n, not only depends on n, but also the instance. That means actual values. Is it correct? Once this case occurs, then what is that we have? We have best case, worst case, and average case. Is that okay? Is that okay? Now you tell me what happens in the best case. What is the best case input in for this algorithm? When does best case occur?
When
When
list
does
is
best
already in
case
sorted
occur?
order.
If the list is already in sorted order. How many times this operation is performed? Swap operation. How many times swap operation is swap operation is performed in best case?
0 times.
Swap count is number of swap. Swap count means, again, you should not mistake it for this. Number of swaps equals to 0. Okay. So what is best case running time in this case? What is best case running time? How many passes are performed? Only one pass. How many elements are compared? Okay, this -1 is not there. No, that's what. Okay. How many comparisons are performed? T of n equal to n-1 comparisons. N-1 comparisons. Hence, its order of growth is n. Order of growth is n. Therefore, T of n is theta of n, or okay, big O of n, or whatever it may be, big omega of n. In the worst case, what happens? In the worst case, what happens? Every time this condition is checked, swap operation is performed. Every time that condition is checked, swap operation is performed. When does worst case occur? When does worst case
When the
occur?
list is exactly in opposite of sorted order.
Thank you very much. Okay. Correct. Now it is something like this. It is something like this. Then every time this condition is checked, swap operation is performed. No? Swap operation is performed. So now that means what? In this case, what is the time? What is how many times that operation is performed? Like the previous case, every time that is performed, for all values it is performed. J equal to 1 to n minus I 1, which is same as n into n minus 1 by 2. What is its order of growth? N square. So that means what is worst case running time? This variant. We can write it as theta of n square or big omega of n square. Average case also same as worst case. I am not going to do that. Okay, same as worst case. Okay. What is the amount of space this algorithm requires? What is the amount of space this algorithm requires? The amount of space this algorithm requires?
Compared to last analysis, n plus 1 more, so n plus 4.
n plus 4. Total amount of space is n plus 4 units of memory. Depending on implementation, it may be n plus 5 units, or it may be n plus 6 units, or we can, in general, I can say n plus some constant units. That means, what is its space complexity? What is its order of growth? N. Hence, what its space complexity is theta of n. Is that correct? What is the amount of additional space it requires? What is the amount of additional space other than input it requires? Either 4 units or 5 units or 6 units or 7 units. Additional space is order of 1.
Constant.
Hence, and that is constant. Order of 1 or theta of 1, that is constant. Hence, this algorithm is in place or not?
Yes, in place.
In place sorting algorithm. Okay. So I stop here. Okay,
Sir,
we'll continue
one
next
doubt,
class.
sir.
Please tell me.
Sir,
Others can
I-
leave. Okay. Okay.
if the array is sorted, swap count will be